Gotta spit my gum out. All right. For problem number 12, it says determine whether the triangles are similar or not. Explain your reasoning. So we could prove similarity with angle, angle. We could prove it with side, angle, side. We could prove it with side, side, side. Those are the ones that we know right now. Now, I think we could probably do angle, angle. How do I know? Well, I don't know yet. We're going to try. The measure of angle U is equal to the measure of angle A, which is equal to 90 degrees. Okay? If you look, I have this little thing here and this little thing here. That means that those are 90 degrees. Now, if I could find a measure, first of all, I don't think it is similar because what's 52 plus 36? It's not 90. Okay? But let me find the measure of angle L and see if it's 52. So remember that the measure of angle L plus the measure of angle U plus the measure of angle Z, all three of those angles have to add up to what? 180 degrees. We know that U is 90. We know that Z is 36. Okay? And I got the measure of angle L plus all this stuff. Now, if I combine like terms, if I say 90 plus 36, now I know it's 126. Why do I do it on the calculator? Well, maybe I make a mistake today. I don't know. Highly unlikely, but. So then that means that the measure of angle L plus 126 is equal to 180 degrees. I subtract 126 from both sides, and I get the measure of angle L is equal to, let me subtract that, okay? 180 minus 126, 54. So that means that the measure of angle L is 54 degrees. It's not congruent to that. So we can say they're not similar. Now, if they would have been the same angle, in other words, if this would have been 52 degrees, we'd be in business. We'd say we'd have ourselves a pair of similar triangles, but we do not. Okay? By the way, just off the top of the head, I know that this is 38 degrees, so we are missing everything. All right, on to number 13. It says determine whether the triangles are similar. If they are, write a similarity statement. Explain your reasoning. Well, this is kind of the same thing. I gotta see. I don't have any information. So let me think out loud for a second. This is what I've taught you so far. You could prove similarity with if you have two congruent angles. You could prove similarity if you have proportional side, an angle that's congruent trapped between the other proportional side. And if you have three sides that are proportional, those are the way that you guys know how to prove similarity. I'm given two angles. I know that this and this are the same. In other words, the measure of angle H is equal to the measure of angle R is equal to 26 degrees. Now, this is 78 and this is 75. So what I'm going to do is solve for this third angle and see if it's equal to 78. I don't think it is, but let's go ahead. So the measure of angle K then, now I'm just going to skip ahead down to this last step. I know that that's equal to 180 minus the sum of these two angles, 75 plus 26. Okay? So I'm going to say 180 minus, in parentheses, 75 plus 26, 79. So K does not equal, in other words, the measure of angle K, which is 79, does not equal the measure of angle Q. Not similar. Now, I don't have any information on the sides, so I can't determine if they're proportional a lot or not. So, in other words, what I thought in my head is, do I have any information on the sides? No. Can I get any information on the sides by doing some fancy math tricks? No. Can't use that. By the way, No information on the sides, can't use that. The only one I have left to prove similarity is angles. Do I know angles? Yeah. This is a congruent angle. Can I prove a second congruent angle? No. MK is not congruent to M or not equal to MQ, or the measure of angle Q. And by the way, P won't, it's not going to be congruent. Okay? This does not equal 75. It equals 76, I think, or something like that. Yeah. All right, moving on to problem number 14. It says, show that triangle EBC is equal to EDA. Well, I know that the measure of angle A is equal to the measure of angle C is equal to 28 degrees, right? Because this angle here is congruent with this angle here, correct? Now, same thing. How do I prove similarity? Angle, angle, side, angle, side, 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 side. Do I have any information on the sides? Nope. Cross those off the list. So how do I have to prove similarity? Angles. Is there a pair of congruent angles that I can prove? Yes. What are they called? Vertical angles. I thought you were going to say I shouldn't be wearing my earbuds while Mr. Adams is teaching. Did I give a speech before I was recording? Take those out of your ear. So yeah, these are vertical angles, right? And what do we know about vertical angles? Always congruent. Are congruent. So that means that the measure of angle BEC is equal to the measure of DEA. I don't need to know what it is, but I got one angle here, I've got a second angle here, similar by what theorem? By angle-angle theorem or angle-angle postulate of similarity. Any questions? You still got your earbud in? You want me just to pause the video? Okay, thank you. Flipping this over, working on problem number 15. All right, we need to prove RST. Which one's RST? This one here is similar. Oh, we need to prove either this one are similar to this one. All right, so I'm just going to pick corresponding parts. So which one do you guys think it is? RST or LMN? Yeah, I think it is LMN, but we got to double check, right? So let's try that. So I'm going to say watch what I do. I'm going to do AB and then BC. So I'm going to say AB over BC. Now they gave us labels. So one way that I could check, first of all, if it is, I noticed that 19 multiplied by 2 is 38, 17 multiplied by 2 is 34, 21 multiplied by 2 is 42. I noticed that. I've got the first two letters here, and then the last two letters here. So now if I'm going to prove that that's similar to LM, I'm going to take the first two letters, put them on top, take the bottom two letters, put them on bottom, or last two letters, put them on bottom. That means I have corresponding parts, corresponding sides. Now if the math works out right, the left-hand side of the equal sign should equal the right-hand side. Let's see. AB is 21. BC is 17. LM is 42. MN is 34. Now if you're good at math, you'll see that 21 times 2 is 42, 17 times 2 is 34. Well, let's go through the process just in case you're not good at math. And I'm going to cross multiply. In other words, I'm going to say 17. I didn't mean that like I was throwing shade or anything. You know who gets hurt and offended by a statement like, if you're not good at math?
The ones not good at math.
The one that are not good at math. And that's okay. We don't all have to be good at everything. I'm sure there's things that I'm not good at. I don't know what they are. Times, teaching. I'm recording. 7 and 14 is equal to 21 times 34. hey, what do you know? Well, bam with the bacon sizzle. 714 does equal, right? 714. So we got lucky on this one. Triangle ABC is similar to triangle LMN. Two more problems, and then we're done for the day. Now's a good time for me to tell you a story with a life lesson. Are you guys ready? No, I'm just messing with you. All right. I'm going to compare the first two letters and then the last two letters. They just, like when I post this video on YouTube, they just want to tell their friends and family, that's me clearing my throat.
Oh my goodness.
That's me. Do you hear that? Listen. All right, so I'm going to compare AB over BC. And then, so the first two letters, last two letters. So I'm going to do it the same here. Why? Because they gave me a label. All right. RT over TS. Plug and chug. AB is equal to. Oh, you know what, though? Well, look what I noticed. I've got RS. That's the first and third letter. Let's do that. Let's change this. I need AB. So I caught myself. Do you see what I did there? Go ahead and erase what you have. Mr. Adams needs AB for sure, right? And we know that AB corresponds to RT. I need that. Why? Because that has this value of X. Now, truth be told, I could solve that problem that way, but that's no fun. I want to do a quadratic and make my life difficult. So, now, on this one has the variable, but that's RS. So, RS is the first and the third letter. So, what do I need to compare that one to? AC. All right, now let's see what we have. AB is 4x minus 42 all over AC, which is just 20. That's going to be equal to RT, which is 36. And then RS is x plus 6. Now we're going to multiply those. Oh man, that's a lot of work. So to cross multiply, I'm going to take x plus 6, multiply that by the other binomial, 4x minus 42. Do you guys know why I've been calling those binomials? 1, 2 terms. Bi meaning 2, nomial meaning terms. So this is an algebraic expression that has 2 terms. If it had 3 terms, which it will in a second when I multiply that out, we'll call it a trinomial. Just think bicycle, tricycle, okay? That has to be set equal to, oh, I didn't really give myself room. Let me do it like this. Let me give myself a little more room. X plus 6 times the quantity 4x minus 42 is equal to, cross multiply this stuff, 20 times 36. And I heard somebody say that equals 720. How about now? Thank you. Please let me know when I'm not on the screen. Sometimes I get caught up in my math. I forget that you guys are watching me. All right, so to multiply this out, you could use a FOIL method. Whenever I FOIL, though, I like to use what I call Adams notation. I don't know where this came from. A student showed me this a long time ago when I first started teaching, and I really like it. When you FOIL, sometimes you forget to multiply a term. Okay? So what I like to do is I like to say x plus 6 and multiply that by 4x minus 42. Holy moly, that's going to be a big number. All right, so what's 4x? What's 4x times x?
4x.
What's 4x times 6? 24x, very good. We're just multiplying the rows times columns. What's x times negative 42? Negative 42x. Holy moly. What's negative 42 times 6? 12 plus 240, 252. Get on my level. Negative 42 times 6. I just want you to process that real quick. I just want you to understand the caliber of mathematician that you are witnessing right now in the flesh. Instead of hating me, you should take that energy and love yourselves. All right, here we go. So that whole thing works out. Now, we've got to combine like terms, though. In other words, this whole thing right here is 4x squared plus 24x, because that's a positive 24x, minus 42x, and I'm running out of room, minus 252. Man, that is a lot. But I've got to combine these like terms. In other words, I'm going to take 24 and minus 42 from it, and that gives me negative 18. So I've got 4, oh man, that really screwed things up. Minus 18x, right, this is combining like terms, minus 252. Oh, we were on a roll until then. Well, let's see how this whole thing works out. So that gets transferred over here, so I'm going to say 4x squared minus 18x minus 252. Now, if I were to look at this right here, how many terms do you see here? 3, right? What do we call that? Trinomial. Tri like tricycle, 3 wheels. Nomial meaning terms. So now when I have a quadratic, we call this a quadratic because a quadratic looks like this: ax squared plus bx plus c. And the best way to solve a quadratic is to set it equal to 0. Is this set equal to 0?
No.
No. How do I set it equal to 0?
Minus 7.
Got a minus 720. Holy moly, this is a lot of work from both sides. I'm trying to educate you guys. So I got 4x squared minus 18x negative 252 minus 720 minus 972 equals 0. Now that's a really big number. So let's reduce it. I thought I'd be able to divide everything by 4, but is 18 divisible by 4? No, not really. So what I'm going to do is divide by 2. So remember, I could divide any term so long as I divide all terms. So this becomes 2x squared. This becomes minus 9x. 972 divided by 2 is 486 equals 0. Now, we got to think of a factor that's 486. In other words, we got to think of two numbers that when we multiply, and it's a negative 486. So one of the numbers has to be positive and one of them has to be negative. Have you guys, can you tell me off the top of your head two numbers that go into 486 that when you add them up it's negative 9? No, but there's a trick. You could cheat a little bit, okay? I know that there isn't that much difference between the two factors. I'm going to confuse you guys. We'll just graph it. So one thing that's cool about the quadratics is I could graph them. So if I graph a quadratic, what's that set equal to? 0, right? So if I plug in my calculator, 2x squared minus 9x minus 486. When I graph this, I'm going to get some crazy number. And I'm going to change the window because I have no idea where this thing's going to be. I know it has a y-integer at a negative 496. So I'm letting the calculator graph it for me. So now I'm going to set the window up. I'm going to say go from negative 20. Now I'm setting the parameters of the window, negative 20 to 20. I want to know where it crosses at 0, so I'm going to say negative 10 to 10. All right, so now if I look at the table, what I'm looking for is when this thing starts to approach 0. So it's between 14 and negative 13 is when it, it's probably 13.5. We're going to get a decimal on this no matter what we do. I think I made a mistake somewhere. No, I can get the answer. I'm just a little disappointed that it's not perfectly worked out. Well, let's keep going and see where the other one is. It's probably not the negative solution because it's like negative 13.5 or somewhere in there. And that's going to grow forever. So I got to go this way. What I'm looking for is when it starts to approach 0. When x equals 18. See how my y value was 0? Yeah. So that's what I was looking for. In other words, what I just discovered on my calculator is that when x equals 0, or I mean when x equals 18, this whole thing equals 0. In other words, if I take this equation, I'll show you what I mean. If I take 2 times the quantity of x, which we think is 18, and I square it, so what I'm going to do is I'm going to plug this equation in, substituting 18 for x, minus 9 times x, but we believe x is 18, minus 486. Okay, so what I'm doing is I'm taking this equation, 2x squared minus 9x minus 486. Okay, and I'm plugging it into this equation. When I hit 0, I should get, or I mean when I hit enter, I should get 0. You see what I did? I found the value of x that made this whole thing equal 0. And on quadratic, zeros are the solution. So that's it, we're done. What was interesting about this is that these are not always set up to where you could factor. And Mr. Adams used a little bit of his math background to kind of figure out how to do it, okay? All right, moving on to the next one. For problem number 17, is that the last one we got to do today? Yeah. All right. For problem number 17, it says determine whether the two angles are similar. So now I see a side angle side and a side angle side, side angle side. The angles are congruent, right? So I could check that off the list. The measure of angle B is equal to the measure of angle Y, which is equal to 66, right? So that works. Now I just need to see if the two sides are proportional. What's 66 times 2? 126, right? What's 32 times 2? 64. So now, just to prove it, I'm going to say AB over BC. And then I'm going to say that should correspond to XY over YW. In other words, 63 over 32 should equal 126 over 64. Cross multiply 63 times 64 should equal 32 times 126. Okay, let's see. I'm going to say 63 times 64. That's 4,032. And then 32 times 126. 4,032. It's the same, right? Are they similar? Yes. So we'll say triangle ABC is similar to triangle. What corresponds to A? I think it's XYW, right?
Yeah.
Okay. Any questions? Okay, that's it.